Hi everyone, my name is Jan and I'm a third year PhD student at the University of Birmingham. Thank you for attending my poster on fluid volumes within the paediatric colon. So a little bit of background. We need physiological data on colonic fluid volumes in children, both to improve our understanding of the colonic absorption process, but also to improve our current models for colonic absorption, so we can make these models more biorelevant. To do this, we could use MRI or magnetic resonance imaging, which has been used before to quantify fluid within the gastrointestinal tract of adults and children. So in a similar way, we are quantifying the amount of fluid within the paediatric colon. To do this, we got 49 MRI datasets that were acquired during routine clinical care from 2 hospitals. All these patients were fast overnight, where some patients also got to drink 500 ml of a Mecacol solution 1 hour before MRI was taken. So this would allow us to give us a fluid-fed population, which is not fully representative of a high-calorie meal, to be precise. Then to extract fluid data from those MRI datasets, we use 2 different protocols, a 2D protocol and a 3D protocol. In this 2D protocol, as you can see here, this MRI dataset is just black and gray. So first we have to identify all the free fluid zones, which you do by thresholding against the cerebrospinal fluid, because the cerebrospinal fluid is free-flowing fluid. So all these voxels with a higher pixel intensity than the CSF are colored red. So these are indicative of free-flowing fluid. Then we would use image J to calculate the areas of all these red zones and then do particle analysis. And if you multiply the areas of all these zones with the thickness of the MRI slice, we would get individual fluid volumes, and then we'd have to manually assign them to be either in the colon or not. We could also, in HORS, we can also make a 3D model of the MRI datasets, and then we could cut out the colon and clean it up a bit in Blender, and then Blender can calculate all the individual pocket volumes. So this gives us both fluid volumes for the entire dataset, but also individual pocket volumes. Then for results, we found that the median fluid volume in the colon was 0.8 ml, whereas the mean fluid volume was 22.5 ml. So this shows that the data is not normally distributed. We also observed a very big inter-individual variability, ranging from 0 ml to 167 ml, which is also observed in adults, as you can see in this figure. You can also see that the mean volume, so 0.8 ml, the median volume, sorry, are quite lower than the ones observed in adults, which are 2 ml or 8 ml. We didn't see any significant influence of age or fat state or sex, which is quite interesting because you would expect age to be a good parameter to predict colonic fluid volumes, which it isn't. So perhaps height or body surface area or BMI index would be a good predictor for the amount of fluid within the paediatric colon. When we compare the amount of fluid within the different segments of the colon, we can see a clear decreasing trend when you go from proximal to distal colon. Again, when we are looking at the individual pocket volumes, we observe that only 9.6% of the pocket volumes, and so from green till red here, are bigger than 1 ml. There's only 9.6 ml. But these 9.6 ml of pockets accounted for more than 94.5% of all the fluid observed, as you can see here. So this shows that only these 9.6% of pockets are really physiologically relevant. We also compared the 2D protocol between two operators to see how reproducible it is. There was a very good correlation observed there. Then we also compared the 2D protocol with the 3D protocol. Again, a very good correlation. So we are very confident our method is both robust and reproducible. We also didn't observe any influence from threshold on the data set. Again, shows us that our extracted data is truthful. To conclude, this is the first study to quantify the fluid volumes within the colon. The median volumes are comparable, but the mean volume is nearly double. And then again, the mean amount of individual pocket volumes, large than 1 ml, is again comparable to adults. We also need more research to compare this to other pediatric populations, and we would like to integrate this into in vitro models or PBPK models to see if we can improve current predictions for colonic absorption in children. So thank you very much for looking at my poster. I hope you enjoyed it. If you have any questions, feel free to ask them using the chat function or the comment function on this conference. I'm also giving a talk, so maybe I can answer your questions there. Thank you very much.